Hello everyone, today we'll start with balancing of simple chemical reactions. To begin with, chemical reaction is made up of two parts. One is the reactant side and the other one is the product side. Reactant side is written on the blunt side of the arrow. Product side is written on the tip side of the arrow. To begin with, you can simply list out the elements given on the reactant side and on the product side, because at the end we have to balance both reactant and product side. So I'm beginning to write the name of elements written on the reactant side. You can see there is a calcium, there's carbon C, there's oxygen O. So write down the number of calcium written on the reactant side. There's only one calcium written on the reactant side, so I'm going to write one calcium. There's one carbon written on the reactant side, so one carbon. There are three oxygens written on the reactant side, so number of oxygen 3. Now on the product side, calcium is 1. So we'll write just one calcium. So you can see reactant side and product side of calcium is equated. Seeing the number of carbon is 1 on the reactant side, product side. So we have 1 carbon on the product side. So yes, carbon's number is also equated. Now seeing the oxygen, we have 1 oxygen here on the product side and 2 oxygens here. So total we have 1 plus 2, 3 oxygens on the product side. So again, the oxygen 2 is equated. You can see oxygen on the reactant side is also 3 and on the product side is also 3. Thus, our oxygen is balanced, our carbon is balanced, calcium is balanced. Coming to the second one, I'm not going to make table for every one of them, but you can simply make table if you get confused. I'll begin with number of elements. You can see we have potassium here. So potassium, on the reactant side, we just have 1 potassium. On the product side, we have 1 potassium. Then we have chlorine. Chlorine, on the reactant side, there are only 1 chlorine. On the product side, there's only 1 chlorine. On the reactant side, we have 3 oxygen. On the product side, we have 2 oxygens. So we need to equate oxygens here. You can see whenever there is a case of 3 and 2 or 1 odd and even, you can simply cross multiply both of the entities. So cross multiplication will give you an even number. You can see if we multiply 3 by 2, if we multiply 3 by 2, we'll get 6 oxygens. So this multiplicand is written on the front side of the compound. So we have made this oxygen 3 into 2, that is number of oxygens are 6 on the reactant side. On the product side, we have 2 oxygens. To make it 6, we can simply multiply it by 3. So there's a cross multiplication we have done here. Whenever you get a situation of odd and even number of oxygens or odd and even number of any kind of compound or element, you can simply cross multiply the numbers. So by doing so, we have equated the number of oxygens on both the sides. But now there's one more problem. The number of potassium and chlorine has also increased to 2. So we can simply write the number of K is 2, Cl is 2. We can simply write down 2 as a multiplicand for KCl. So you can see the equation is already balanced now. Coming to the next equation, we have P4O10 carbon on the reactant side and P4CO on the product side. So it seems like a very easy equation. See, we have 4 phosphorus here and 4 phosphorus on the product side. 10 oxygen on the reactant side, 1 oxygen on the reactant side. So let's make it 10. So we have 10 oxygen on the product side too. We have 1 carbon here, but now the number of carbon has been increased to 10 on the product side. So number of carbon is 10. On the product side, we're simply adding 10 carbon on the reactant side to make it equal. Now you can see there are 4 phosphorus, 10 oxygen, 10 oxygen, 10 carbons, 10 carbons. So the equation is finally balanced. Coming to the next equation, this is an interesting equation again. See, we have 2 hydrogen here, but 3 hydrogen on this side. 2 nitrogen on reactant side, but only 1 nitrogen on product side. So we simply have a situation of even and odd. So since we have 2 hydrogen on reactant side and 3 hydrogen on product side. What do? We simply cross multiply this. Cross multiply as in you multiply 3 with 2 hydrogen and 2 with 3 hydrogen. So these multiplicants have to be written in front of the element. So see, we are multiplying 3 with the reactant side of hydrogen. 3 with reactant side of hydrogen. That makes our hydrogen 6. 2 3s are 6. And on the product side, again, there are 3 hydrogens, so I will simply multiply it by 2 and write the 2 in front of whole compound. So we have 3 2s are 6 hydrogen on the product side. Now since hydrogen is balanced, we need to see for the nitrogen part. You see there are 2 nitrogen on the reactant side. After balancing the hydrogen, we have 2 nitrogen on the product side. So nitrogen is itself balanced. Coming next to the H2Cl2 equation. This equation again is very simple. You see we have 2 hydrogen, 2 chlorine on the reactant side and only 1 hydrogen and 1 chlorine on the product side. We simply put a 2 in front of the whole product. By doing this, we have 2 hydrogen and 2 chlorine on the product side, and that simply makes the equation balanced. Coming to the next equation, we have one Cu, 1 O on the reactant side. We have 1 Cu, 1 O on the product side, 1 H2 on the reactant side, 1 H2 on the product side. So the equation is already balanced. So what can you take from this very video is, first, if you get confused in balancing the equations, simply make a chart of elements on reactant side and product side and see if those elements are equated or not. At the end of reaction, you have to equate the reactant side and the product side. The second thing you can take away from this very video is whenever you get a situation of odd and even, for example, the one you got in this case of oxygen O3 and oxygen O2, you can simply cross multiply. So whenever you get odd even situation for elements on reactant and product side, simply cross multiply them. Cross multiply as in multiply the odd with even part. So this is the second takeaway you can use. So this was the preliminary part of your reactions. We'll come up with the second part of the reactions, which are a bit of complex. Till then, you can simply screenshot these reactions and try to do it at your home.